Hello children, we are back to chapter number 4, quadratic equation of standard 10. Now we are just nearing the end of the chapter. We are here with exercise 4.4. We are now going to talk more about the nature of the roots. As such, we have already studied a little bit about the nature of the roots. We'll do a quick recapitulation. Quadratic formula, you know that. The discriminant part is nothing but b square minus 4ac, that is having a name given to it. We represent it by capital letter D and it is b square minus 4ac, that is the discriminant. We are going to use this quadratic formula now. The nature of the roots now. Children, when b square minus 4ac is greater than 0, we will say that two distinct real roots, they'll occur. The roots, the solutions, they'll be 2 in number and distinct also. Then if b square minus 4ac equal to 0, then the roots will be equal, because the square root part, it vanishes and you are left out with 2 equal real roots. There is one more condition, the third one, b square minus 4ac is less than 0. In that case, there will not be any real roots. So, whenever you get the third condition, you need not solve also. Question number 1, it's quite easy. Find the nature of the roots of the following quadratic equations. If the real roots exist, find them. If they exist, then only you have to proceed. Now, the very first sub-question, we are going to select A, B and C from here. A is 2, B is minus 3, consider the sign also, and C equal to 5. Now, let's find the discriminant, that is B square minus 4AC. Substitute the value and get the answer. In this case, it comes out to be minus 31. Children, this is less than 0. Whenever the discriminant is less than 0, there will not be any real roots. So you need not solve further. You'll just specify that there exist no real roots. Let's proceed to the next sub-question. This is the sub-question. Check out A, B and C. The next step is substituting A, B, C in the discriminant formula. So this is what you get. Solve further. Now, this b square, it is minus 4 root 3. Square of negative is always positive. 4 square 16, root 3 square is 3. 16 3s are 48. This is how you get it. Further you solve and you get b square minus 4ac to be equal to 0. Children, when it is equal to 0, it will have equal roots. So let's proceed. Substitute in the formula, that discriminant part goes away and this is what you are left out with, minus b upon 2a. Substitute and this is what is the value of x. Both the roots, they are equal. So the roots will be 2 root 3 upon 3. The next question, question number 2. Find the values of k for each of the following quadratic equations so that they have 2 equal roots. Now these are little bit tricky but quite easy type of questions. You have the equation, that is the quadratic one. You have to select A, B, C as usual. Now you are already told that the roots are equal. The condition for the roots to be equal is b square minus 4ac equal to 0. Now you have to substitute a, b, c and this is what you get. Solve it further. It is k square minus 24 equal to 0. 24 transposed on the other side and k will be square root of the value. So you will always consider plus minus both the values. It is compulsory for you to write both the values. And the value of k will be plus minus 2 root 6. This is how you have got the value for k. One more example. This is what is the equation. You solve it. You open the bracket and you get this quadratic equation. The next step is selecting A, B, C, and then for the equal roots, because it's already told in the question that the roots are equal, you'll write that b square minus 4ac equal to 0. You are considering this root to be equal to 0 because roots are equal. Substitute the value and you get k equal to 0 or k equal to 6. Now, can k be equal to 0, children? It is impossible. Why? Because if k becomes 0, here the first term, that is the square term, x square term, that will vanish. Ax square will not be there and the equation will convert into a linear equation. So, we'll drop that value of k and we'll keep k equal to 6. The next question. Question number 3. Is it possible to design a rectangular mango grove? It's a garden, mango garden. Mango grove whose length is twice its breadth and the area is 800 meters square. We are asked whether this is possible. And if it is possible, then we'll find out the length and the breadth. So as usual, we'll consider the breadth to be x, length to be 2x. Moreover, you are told that the area is 800. So you substitute the value length into breadth equal to area. So substitute all the values and you get a quadratic equation 2x square equal to 800, which can be solved further. So let us solve for x. X comes out to be plus minus 20. Again, negative value not possible because breadth cannot be negative. So, we'll consider the positive value of x, that is x equal to 20. So, we'll say that the breadth of the rectangular mango groove, it is 20. And in that case, length is twice of it, that is 40 meter. And this was very much possible. So, keep solving. Have a great time. Thank you for now. We have already completed this chapter. We'll be continuing with another chapter in the coming videos. Thank you.